So welcome to video 2, a short video on the Monty Hall problem as part of our course ST3 on probability. So if you're unfamiliar with the Monty Hall problem, the idea is simply this, that behind one door is a car, behind the other two doors is a goat. You have a chance to use one door only. After you do that, I will reveal one door that you did not select. This door I open never contains that car. And the question for you is, do you want to stick with your original selection, or do you want to switch to the other door? So remember, you have 3 doors at the start, 2 goats and 1 car. You have one door that is wrong is eliminated, and you basically have 2 options. Now, this is the Monty Hall problem. You have 2 kind of outcomes. You chose the car, I revealed a goat, and the other door contains a goat. Or you chose a goat, I revealed a goat, and the other door contains the car. This kind of thinks of it as 2 different outcomes. We know the probability of having a car at the start is 1/3. The probability of choosing a goat at the start is 2/3. And therefore, this action of revealing a goat is something that we should consider, because that's 1/3 of the different probabilities. So this has an effect. And these effects are equal across the 2 different options. So what's interesting is that the probability of choosing a car or goat at the start are different. It's 1/3 and 2/3. And our probability of improving our chance of actually getting the car is better at the end by switching to the different door that we didn't choose at the start. When you think about this using probability trees or probability diagrams, so we really have 3 outcomes. You choose the car at the start, I reveal the goat, and the other door contains the goat. So that's shown here. We choose it. This is wrong. This is wrong. That's 1/3 of the possible options. Another option is I choose the goat 1, which is here. The person reveals goat 2 is shown, and then the car is the other door. The other option is the reverse, that I choose goat 2. This one is revealed, and the car is behind the other door. Each of these has 2/3 of different options. So what we're thinking about is the probability of our selection given a particular action. The probability selection at the start is 1/3. That's what we're starting with. But then we have the action that one door is eliminated from this. So for this top option here, which contains initially 1/3 of our probabilities, if we stick with the car, we'll be successful in these 2 options. However, down below, if we choose either of these 2 options where we just stick with the same selection, that means 2/3 of the time we'll be wrong. So our outcomes are the same as if our random selection at the start, 2/3 of the time will be incorrect. So the key thing is the probability of winning the car with no switch is the same as the original selection. We can show that graphically displayed here, that we have 1/3 of options here at the top, 1/3 here for the goat, and 1/3 here for the second goat. So winning and losing, our chances are quite different and the same as they are at the start. However, what happens is that one goat option is removed. So that should improve our options. But you see here, if we don't change our mind, then our options are 1/3 and 2/3. So if you look at this option here, where we're at halfway stage and we select one of these outcomes, if we selected the car originally and go for that option, and then, sorry, if we select the goat originally and switch to the car, our chance of winning are 1/4 here. And same here on the other side, our switch, if we chose the car originally, switch to the goat, our chances are here. So this diagram doesn't work through if the probability of winning and being successful. So we can look at there is that if we probability of winning car, if we switch, is actually twice that of the original one, it becomes 2/3. So if we choose the car first, a goat is revealed, and we choose the goat, our chance of losing is 1/6. If we choose the car at start and switch to the other goat, and the goat is revealed, we get 1/6 again. However, if we choose a goat at the start, we then switch, our probability of winning is going to be 1/3, because this goat is removed and we switch to this car. Same way, if we switch we start with this goat and switch to this car, but because this one is eliminated, our chances of that options are 1/3. So you can see there, we're only unlucky if we actually chose the car at the start in this strategy. So what this illustrates is that your intuition may be misleading. Looking at tree diagrams on probability trees are useful, and you can look at the multi-hole problem in a paper on the end drive as well if you want to think about it in more detail.